Okay, so now we're moving to the last part of this unit, and we look at the tension force on an object, something like this. If we had a cable car that was connected like this, we would have, essentially an incline involved with tension here. So tension would be coming up, and we'd have the incline here along the tracks. And so let's go ahead and explore that. Okay, so let's say mass 1 is hanging here on the incline, mass 2 is hanging downwards. In this case, we're again going to set up two separate free body diagrams, set up the sum of the forces separately for each and work it from there. So let's set up the coordinate axis, going the positive x to the downward part here and then the negative x. We actually don't know. Sometimes, the system may actually accelerate the other direction with this kind of a problem. So whatever final value that we get, if it's negative, we know that the masses are going the other way, right? Okay, so let's set up the free body diagram of mass 1. It's actually on an incline, so we have the force of gravity straight down. We have the normal force going straight up, force of tension going up the ramp, and then force of gravity in the x acting against us. Force of gravity in the y is equal and opposite to the normal force. For mass 2, it's the same as before, force of tension up, force of gravity down. We set up the sum of the forces in the x here for, along our x-axis right here. And we have the positive force of tension plus the negative force of gravity in the x equals m1 a in the x. So in this case, what we're going to have to do is we continue this. We have the force of tension plus, how do we get, force of gravity in the x? That is the opposite side, right, of this, whatever angle this is. So we're going to have mg, well actually m1g times the sine of theta, right? And that should be a negative in front of this, because the negative acting, against us, equals m1 a in the x. Okay. Now over here we have the negative force of tension plus positive m2g equals m2 a in the x. So the challenge here is to recognize with the incline, you've got to be careful with your trig as you do that. We can bring this again to the other side and then substitute it into tension. Just got to be careful about the sign here. So why don't you try that? Why don't you see if you can derive the acceleration for the system, solving for acceleration over here. And so pause the clip, and then when you're ready, you can continue. Okay, so when we substitute in there, we should have, we distribute the negative m1a minus m1g sine theta plus m2g equals m2a. We can bring m1a over to the other side, isolate for acceleration, and this will be the acceleration of the system, g times m2 minus m1 sine theta divided by m2 plus m1. So what I want you to try is to derive this from scratch, and then you can use these values. The 10 kilogram here is mass 1, the mass 2 as 25 kilograms, and try your best to derive the acceleration equation from scratch. And then once you do that, you can calculate the tension as well. And so give your best shot with that, and when you're ready, you can hit play to continue. Okay, so we should get positive force of tension plus the negative force of gravity in the x equals m1a. And over here, negative force of tension plus the positive m2g, which is force of gravity, and then m2a in the x. We substitute in, and we should get negative m1a minus m2g sine theta plus m2g equals m2a. It's isolating for acceleration, and this should be what we got, g times m2 minus m1 sine theta divided by m2 plus m1, and we should get the acceleration, which is 5.02 meters per second squared, with a tension force of 119.5. So because this came out as positive, we know that the system is going to accelerate in the positive, this direction, as it goes down. If we got a negative value, we know that it's actually accelerating the other way. Okay, so here's another one. If you want to practice this, you can see if you can set up the equation again, and the masses here are 110 kilograms and 35 is the one hanging down. And so yeah, go ahead and do your best, and when you're ready you can hit play and see if you got the values. Okay, so your equation should have come out as g n2 minus m1 sine theta divided by m2 plus m1, and the acceleration of the system is negative 2.89 meters per second squared.